What is a clean room? Clean rooms are rooms with special filtration to remove particles and dirt from the room. This video covers what a clean room is, the invention of clean rooms, how they work, what clean room classifications are, and what industries use clean rooms. It will also cover different types of clean rooms, recirculating versus one-pass clean rooms, and hardwall versus softwall clean rooms. Clean rooms usually have custom HVAC systems to control temperature, humidity, and room temperature. Industries that use clean rooms include semiconductor, medical device, pharmaceutical, aerospace, USG 797 compounding pharmacies, and R&D laboratories. Pharmaceutical clean rooms and medical device clean rooms are required by the FDA to meet CGMP standards. Who invented the clean room? Willis Whitfield invented the clean room in 1960 at Sandia National Laboratories to solve problems of dust particles causing reliability and quality issues with nuclear weapon components. The design includes special HEPA filters to clean the air and a raised floor to return the air back to the filters. The resulting recirculating design and the laminar airflow produced rooms that are 1,000 times cleaner than anything that existed at the time. Because Sandia was a government laboratory, the revolutionary cleanroom design was shared for free with the entire world. Early industrial uses of cleanrooms included RCA and General Motors. How cleanrooms work. The HEPA fan filter units on the ceiling remove 99.97% of particles greater than 0.3 microns from the air and push cleanroom air into the room. The clean air passes through the room exits through a low wall air return, and then passes through the air return walls back to the negative pressure plenum, where the air is cleaned again and reused. Only HEPA filtered air is allowed to enter the clean room. Clean rooms are net heat generators due to the friction of air passing at high velocity and volume through the HEPA filters, clean room personnel, lighting, and equipment inside of the clean room. Most clean rooms have a dedicated AC that injects cool 55-degree air into the plenum, or mixes with reciprocating air to keep the clean room cool. Some clean rooms have a gown room or airlock to prevent dirt from entering the clean room every time someone enters or exits. Only one door of the airlock can be opened at once, which prevents air from flowing directly from the outside to the inside. Personnel working in clean rooms wear special garments to prevent them from bringing particles into the clean room. The clean room bunny suits encapsulate particles on an operator's clothing, shoes, or skins. These garments never leave the clean room, so they stay sterile. It is also common to wear gloves and face masks to prevent exhaling particles into the clean rooms. Clean room classifications. Clean rooms are classified by the number of particles in a given volume of air. The FED standard 209E counts the number of particles per cubic foot. The ISO 14644-1 standard counts the number of particles per cubic meter. Other criteria to meet clean room classes include air exchange per hour of HEPA filtered air. The more air exchange per hour of HEPA filtered air, the less particles will be in the clean room. Types of clean rooms. Clean rooms can be either recirculating or one-pass design. Recirculating clean rooms are most common because they continuously clean the already clean clean room air, resulting in less particles in the clean room. They are also the only design that allows clean room air conditioning and humidity control. One-pass clean rooms pull air from outside the clean room to the air using HEPA fan filter units, push the filter air into the clean room, and then finally exhaust the air back outside the clean room. One-pass clean rooms do not have the same temperature or humidity control. The one-pass design is typically used to save money, or if air outside the clean room is already being temperature controlled. Clean rooms can be either a conventional or modular or softwall design. Conventional construction clean rooms are typically chipboard and studs with epoxy paint or sheet FRP exterior. The HEPA fan filter units are typically ducted as opposed to having a plenum. This is an older method of cleanroom construction typically used for lower class clean rooms. Modular clean rooms are prefabricated in our factory and then assembled on site. This allows for faster design and construction than conventional construction clean rooms. The components are like a Lego set, so they are easy to modify or disassemble. Modular clean rooms can be designed and built in less than half time of a conventional construction clean room. Softwall cleanrooms use clear vinyl instead of hard walls to keep particulates out of the cleanroom. They use HEPA fan filter units to provide clean air and a one-pass design. Cleanroom strip curtains are used to provide entrance and access to the cleanroom. They are not as clean as hardwall cleanrooms and do not provide positive pressure to keep dirt from entering the cleanroom. In addition, since they are one-pass design, softwall cleanrooms cannot offer temperature or humidity control. What industries use cleanrooms? Some industries that use cleanrooms include semiconductor device manufacturing, medical device manufacturing, pharmaceutical device manufacturing, aerospace manufacturing, food processing, USP 7x7, compounding, pharmacies, and research development laboratories. Semiconductor cleanrooms are easily recognizable by the amber lighting used for photolithography processing areas. Due to the small feature size on computer chips, these semiconductor cleanrooms are typically class 100 or even class 10. In addition, they require tight temperature and humidity control, which results in the use of raised cleanroom flooring to provide the absolute best AMR airflow. Medical device cleanrooms are subject to FDA validation and must meet CGMP practices standards. They are typically ISO 7 or 8. Cleanroom testing, including both non-viable and viable particle testing, is very common. Rigorous cleaning schedules and monitoring are a typical part of medical device cleanrooms. Pharmaceutical cleanrooms are also subject to FDA validation and must also meet CGMP standards. Pharmaceutical cleanrooms regularly clean with powerful chemicals to prevent bacterial or microorganism growth. Therefore, they use chemically resistant FRP walls and coved heat-welded vinyl or epoxy. Both of these are non-viable, and viable particle testing must be done on a regular basis. Aerospace cleanrooms can be used for component assembly, such as rocket engines, GPS systems, and more, or systems assembly, such as satellites. In addition to cleanliness, electrostatic discharge is a significant concern. Static dissipated walls and flooring are a common feature of aeroscopic cleanrooms. System assembly aerospace cleanrooms typically have very high ceilings and doors to allow space for large satellites. Cleanrooms are also often used for food processing. Common applications include energy drinks, gummy bears, food supplements, and produce processing. Equipment used by these cleanrooms is typically NSF certified. These facilities are also regulated by the FDA. Cleanrooms are used for many other industries, including printed circuit board manufacturing, paint lines, lamination lines, plastic injection molding, 3D printing, laser manufacturing, and mask manufacturing. Any product vulnerable to contamination or requiring a particle-free environment may require cleanrooms to ensure high yields and material quality. Research and development cleanrooms are typically used by national laboratories and universities to carry out cutting-edge research. Since they are measuring in parts per millions or fabricating nanoscale size devices, they require high-class cleanrooms to ensure their research is accurate and effective. Extremely tight temperature and humidity controls are common. Other requirements may include metal-free, stainless steel walls, HEPA exhaust filtration, and laser interlocks. Invented in 1960, cleanrooms are rooms that use HEPA or OPA filtration to remove particles and dirt from the room. The FED, STD 209E, and ISO 14644-1 standards are used to classify cleanrooms by their particles per volume. There are different types of cleanroom designs, recirculating and one-pass. Different material can be used to build cleanrooms: conventional construction, modular construction, or softwall. Industries that use cleanrooms include but are not limited to the semiconductor, medical device, pharmaceutical, aerospace, and R&D industries. Make sure to check out other American Cleanroom Systems content.